Aloha, Rich Halverson here. This is ITS 128, second week. I hope my video is working. I don't see me moving. Anyway, so let me share my screen. We'll get started. Sure hope this starts going. All right, put this over here. I'm gonna put this over here. Oh, you can't see this, but I'm gonna put it over here. And are you able to see me? Are you? Oh, can maybe just one of you? Just one of you needs to log in, possibly. Just take a look. It's okay. I don't care. That's fine. All right. I did upload grades, and I'm not sure which class this is, but this is my student account, so we shouldn't see anything. We shouldn't see anything bad. All right, so we shouldn't see anybody else's stuff. And so what I've done is I've just loaded up a bunch of bogus scores just so you can see how this works. So participation, all the participations are counted, all the challenges are counted, all of these all the initial set of chapter programs are counted, but the lowest, of the remaining programs, and they're just like follow-ons to these, I'll drop the lowest 8. Okay, so that should give you some leeway. Let's see, what else was I going to say? And also though, what I've done, okay, my classes, when I upload my scores, I like to give you blanks for stuff that's not due yet, and that way it doesn't go into your grade. So you see your grade like so far, assuming you keep up with everything. Mr. Teho Yum, his students have requested, or majority have requested, that they, and I could do it this way too if you're interested, is you leave zeros in there, because when you download the scores from Zybooks, there's zeros for the future because you haven't done them yet. But when zeros go in, those actually go into the computation of your grade so far. So right now, like all those grades are like, now for those students are like 5%, 6%. But as long as you know that you're only the beginning is being counted, then that shouldn't worry you. The advantage of the way he does it is that if you want, you can just work until you get an A, and then you can stop. And I don't have any problem with that. I don't think he does. So you're able to see right when you get the score. Like maybe some people, I know all you guys want to get an A, but some students don't. B is great. Hey, I'm good with a B, and so they work till they get a B, or it could be that they aren't going to go into this as a career. They just want to learn it, and they got some other classes that are like way harder, way more important to them, and so they want to get a B. So it's up to you. But so just know if you're in one of my sections, I do it one way and he does it the other way. If you'd like me to fill in the zeros or anything just on your scores, you can email me and say, hey, what would my score be if I stop? I'm happy to tell you that, because there are lots of times people ask me that at the end. Towards the end, they asked me if they asked me if they have an A yet, and oftentimes they do, especially those that ask. All right, so today I'm just going to continue on with our textbook chapter 2. Let's see, let's go to Zybooks. Let's go here. Oh, I can go to, let's see, let me go to one of these classes, and I'm going to hit Zybooks textbook. All right, here we go. And I think I did a lab last time. Why don't I start with variables and expressions? And let's see how people have done so far. So I'm able to look and see how people have progressed so far. And we got a couple of people here, well, maybe one person. Let's see how many people are in this. Okay, so I guess this might be like one person is working ahead. Very good for you. Maybe the person's in this class, but this is all three classes here. So let's just get started. I guess I'm going to kind of assume that you you don't know how to or that you're new to programming. I'm going to assume that you're new to programming, and if you're not new to programming, it's often comforting to be in a situation where you're being taught something that you already know, because it reinforces and it gives you a different perspective and all that. Okay, so there's a concept of a variable and there's a concept of an assignment. And variables are slots in the are memory locations. They store data, and you store numbers, or you store data values into a variable, and then you're able to use that variable in an expression to compute other stuff. And again, so we this idea of remembering a variable, if we go through these little exercises here, you're driving a bus and the bus starts with 5 people, 3 people get out. So how many do you have now? I guess you have 8, because this people is a variable. It's equals 5. Add 3 to it and you get 8. And then check, and oh, good, I got that right. Next. You're driving your bus. The bus starts with 5 people, 3 people get on. That gives me 8. Now 2 people get off, and so now I have 6. This is very so simple. What's next? 4 people get off. Now I have 2. 5 people get on. I'm gonna answer it wrong just to see what happens when I get it wrong. I'm gonna, instead of 7, I'm gonna put 6. Boom. Oh, is that what it is? Okay, now you're expected to know what the answer to that is, I guess. Okay, so let me just do next here. 5 people get on. That's 7. Very good. And then 4 people get on. Okay, 4 people get on. So now we're at 11. Okay, so anyway, that's the concept of variable, and these are like assignment statements. These are assignment statements because they basically assign new values. Now, there's something implicit here, and that is you start with what you already have in the variable, and then you add 3 to it. And then after that, you start what's in there, what's in there now, and then you take away 2, so on. So anyway, you'll see that. So here's how we would do it in programming. The variable is always on the left, and you're always taking what's on the right and evaluating what's on the right, and then storing that value into what's on the left. And then you go down to the next one, and you keep on going like that. And if on the left you always see a different variable, well, then that means it's a new variable that's being used. But on the right, these are expressions, and this is an easy expression. It's just 5. This expression equals whatever's in the x variable. We see it's 3. So no, it's 5 because it just got assigned to 5. See, once this assigns x to 5, now x is equal to 5. So now y is equal to 5, and then z is equal to 5 plus 2 is 7. So 7 goes in there, and then 3 goes into x. Now, when 3 goes into x, it doesn't change anything up here. When this assignment statement is executed, then it takes whatever the value is for x, and uses that value, takes whatever value is for X at the time, uses that value, and that's it. Doesn't matter what happens to X after that, okay? It's different in other other kind of programming languages and stuff, data flow, but in programming, that's how that works, okay? This thing only affects the future. Okay, anyway, now in programming, it's different than algebra, because in algebra, something like this works, where you have an expression on the left-hand side and you got some value on the right-hand side. And in algebra, you're stating a fact. You're stating that X plus Y equals 5. It's up to you to figure out what X is and what Y is, but when you take those two together, it equals 5, and that's a statement of fact. Whereas in programming, you're saying, do this, put 5 into the X, and that's why you can end up with something like X equals X plus 2, as you'll see. Now, you should click through these things so you are able to get all the points. I guess I should see there's 5. So you can do this kind of thing. I guess when I go through this, I should click through them so I get it over with. You can do it too. All right, so anyway, so we're done, and we get the check mark there. Quiz. So here's a test of whether you understood. Okay, so this is not valid because the left side of this so-called assignment statement, it's assignment statement because you're assigning a value, is always just a single variable. It's always a single variable that's going to get written into. Some variables cannot be written into. They're not called variables, they're called constants. But sometimes you can have something that looks like a variable on the left-hand side, but it's not. So the left-hand side has to be a variable and has to be able to be written into. The right-hand side can be anything, but it's got to evaluate to something. It's an expression. It's an expression that evaluates to something. It's not. There's no equal sign on the right-hand side most of the time. All right, so go through this. X equals 9, Y equals X plus 1. What is X? Well, it's still 9. Here's a participation activity. Trace the variable values. Select the correct values for X, Y, and Z after the following statements execute. Okay, so let's start with this. These are like challenge activities, aren't they? Well, let's see. You can click through that one. Why don't let's do a challenge activity. Okay, enter the output of the variable assignments. No, print includes a new line, so make sure you do a new line. All right, let's start this. And we're going to say type the program's output. Well, we're going to start out with X equals 9. So X equals 9, Y equals 6. And then we're going to print X, comma, Y. Well, so that's going to be print X, and then a space, and then a Y, and then a carriage return, new line. So that's just going to be 9 space 6 new line. All right. This one's going to be 9 5 new line. 9 5 new line. These are all too easy. 5 3 new line. Oh, no. 8 3 new line. Because this is the one that matters. Because it's the last one. X and Y. So it's going to be first Y is equal to 7, and then X is equal to whatever Y was. Well, we know Y is equal to 7, so that means X must now equal 7. So the answer is 7 space 7. And then the number 5 is Y is 10. Y plus 2 is 12, and this 12 here gets stored into the X. So X is 12 because we're printing X first. X is 12, and then we're going to print the 10, which is the last. What's the last value that was stored into Y? well, it's 10, so 10. And the last one is y is equal to 5, x is equal to y plus 2. So now x is equal to 7. And then y gets overwritten and it's 13. So x is equal to 7 and y is now equal to 13. See, so that's, and I got all the points here. Assignments with variable on the left. Okay. So this is saying that, you know, as I was saying before, this is not algebra. This is describing a command, or it's an action. There's a before and after with algebra, and you see x equals some equation. You know, there's no before and after. Well, there's no before and after because there's actually stating a fact. Here, there's a before and after. So that's why you can have something like this, where I'm going to start this up. Where you have x, and then you take the old value of x, or you take the current value of x, multiply that by 20, and store that back into x, and so now x has a new value. And then you do it again. Well, you take whatever is in x, and it's 20 because this just happened. And then you multiply it by 20, so what's 20 times 20? That's 400, and so now x is equal to 400. A person with measles may cause 400 people to be infected in 2 weeks. Oh, that's pretty amazing. Okay, so this gets executed, then that gets executed, and then we print these. Lo and behold. So that's this idea where you can see this doesn't make any sense in algebra. Well, it does. If x is 0, yeah, if this is algebra, then x is 0, because never mind. Okay, so variables on both sides. So here's make sure you understand how this works. X is equal to 5, and then you add 7 to that x, that equals 12, and so now x is equal to 12. You're supposed to say what it is, and so you say 12, and that's the answer. All right, another challenge here. See, I want to go to 3 o'clock. Assign variable num oranges equal to 95. The output is 95. Oh, so I just have to assign this value equal to that. I'm going to be lazy. I'm going to replace this with and equal. There you go. Got all the points. What's next? Oh, I just did that. All right. Num roses is read from input. This is confusing to new people. I don't know why they do it this way, but they could just as easily put this on 2 lines and it's less confusing. But here we're asking the user to input something. That's the user's me. When this program runs, I'm the user. And then whatever I type in is converted to an integer. And so that means what I type in has to be convertible to an integer. It has to look like an integer, but it's not. It's characters. When you type it on a computer, and I type in 546, I'm actually typing the character 5, and then I'm typing the character 4, and I'm typing the character 6, and that's not the value 546, but then this int thing converts it into the value 946, and then you can manipulate that variable like it's a number. Before you do this, you can't manipulate it like a number. You have to manipulate it like 3 characters. You can append more characters onto it. You can delete characters out of the middle, and so on. All right, so we're supposed to take this, and then we're supposed to we're supposed to read what the user enters, and then we're supposed to add 4 rows. Then we're supposed to add 4 to it, because the scenario here is you purchase 4 more roses, and then you want to see what the remaining number of roses are left. So if the input is 7, oh no, okay, we're subtracting them. So we start out with 7 roses, somebody comes in and buys 4 roses, and the output is 3 roses. So what's the code to do that? Num roses equals num roses minus 4. Is that right? Did I spell something wrong? Oh, I did this. Okay, I could do. I wonder what would happen if I just do this. Okay, this should work. It does work. So, but really what they were after was this. You can skip this second step and just put this up here. They were really looking for this as an answer, but I think this probably works. All right, so let's what's next? Num students is read from input representing the school's number of students, then an enrollment increases 2 times as many students, right? A statement that multiplies num students by 2. So here we're reading in num students and we're writing num students back out again. So we just need to multiply num students by 2, and we can do num students equals num students times 2. And that should work. And multiplication is commutative. What does that mean? That means it's the same as 2 times. Doesn't matter which one you put first. Okay, what's the last one? Initial pair of boots is read from input. Assign a pair of sandals with the same value as pair of boots. Then assign pair of boots the sum of pair of sandals and 2. Lastly, assign total pairs to the sum of the pairs of boots and the sum of the pairs of sandals. Okay, so we read in some pairs of boots, and then we want to assign pairs of sandals to the same value as pairs of boots. So we want to do this. Pair of sandals with the same value as pair of boots. Then assign pair of boots with the sum of the num pairs of sandals and 2. So we have pairs of boots equals the sum of the pair of sandals times 2. So I'm just going to be extra lazy here. Pair of boots is equal to pairs of sandals and to a sum of pair of sandals and 2. So I'm just going to be there. That's the pair of sandals plus 2. That's going to be the sum of the pairs of sandals and 2, and then that stores into pairs of boots. And then lastly, assign total pairs. So total pairs equals the pairs of boots plus pairs of sandals. Okay, let's see what this does. All right, excellent. Okay, so identifiers gives names to various items. It's such as variables. It's several. Whenever you're naming something, and so far we've only named variables, but we name other things. We name functions. We name constants, which are like variables. And see, do we call these identifiers too? There's also all of the special words in Python, those are called identifiers. And so an identifier is a name, and the one thing about it's a name of something, and it always starts with a letter. An underscore is like a letter. So you can think of an underscore like a letter. So in other words, a variable could start with an underscore. An identifier could start with an underscore or a letter. It could be capital or lowercase. And capital is different than lowercase in Python identifiers. Capitals are different than lowercases in other languages. That's not true. HTML is not true. But an identifier can also have some digits in it, but it just can't be the first one. The first character cannot be a digit, but the rest of them can be, or any of the rest of them can be. It's case sensitive, as I said. And then there's some names that you cannot use, like you can't use any of the special words in Python. And you know, like, and this is a special word. This is a special word, as you've seen. And then you'll see other special words like while and if and all those other things. All right, so are these valid words? This is a valid word. 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 This is not a valid word because it cannot have a space in there. This is not a valid word, valid name, because it starts with a digit, starts with a number, starts with a digit. This is okay. This is not okay because that's not a valid character. It's got to be a letter or a number or an underscore. I'm worried about this one. I think, is this a reserved word? I can't remember. I'm going to say invalid. Oh, I guess it's okay. This was wrong. All right, this must be valid then too. All right. All right, so you should make your, your variable names meaningful. Back when the first job I had programming was college, and I was a Fortran programmer. And that wasn't it was not my first language. My first language was BASIC, which I learned in high school. But in Fortran, your variable names were limited to 7 characters. And so this was impossible. You couldn't do anything like that, and you couldn't have underscores either. So but anyway, then a language called Algol came along. Anyway. So these are reserved words. You can't have variables that are these names because these have special meaning in Python. Cute. Okay. In Python, we have it's not quite the same. This is a little unique to Python. I wonder where I'm recording. I hope I'm recording in the right place. I am recording, all right? Yeah, I am. An object represents a value that is automatically created when executing a line of code. So when you execute something like this, it creates an object that puts in, and it's got that represents the value 4. And so a value is like it can be however many memory locations it takes to store the object. And there can be more than just the value stored in the object. There might be a size, the number of memory locations it takes to store that object, and so on. So I guess it's good to go through these things here. If you print 2 plus 2, it's going to create an object called 4, which represents this. And then here, if we print the 2 plus 2, it's going to print the memory, and then it's going to throw it away because it doesn't need it anymore. And there was no memory location, there was no name attached to it or anything, so that's fine. A new object, now when this executes, a new object called X is created that stores the value 7 in it. And then you know, when you want to print X, it's able to go get X and print out the value 7. There's some other things you'll see here, like name binding is the process of associating names with interpreter objects. This isn't really that important. Let's see, types of objects. There's properties of objects. An object has a value. These are values. It has a type. So it can be like an integer or a string. This can be an integer or a string. It can be either a string of 2 characters, or it can be an integer with the value 55. You know, this is a string. There's no integer equivalent to this, but there is to this and so on. So you're able to like ask the interpreter what type a particular object is. You know, these are all names now. We can think of these names as names of objects instead of variables. There's the type determines, and this isn't really that important now, mutability. You're going to have to understand mutability when we get into other kinds of objects for storing information, like lists, and where lists can either be, oh, by the way, mutable means changeable. It means, can you change it? If it's mutable, it means you can change it. If it's immutable, it means you can't change it. It's just a fancy way of saying you can change it, or it's there for the life of the program. And so some objects you can change their value, and it's still the same object, but the value changes. Like all variables are that way. You can change the value of the variable, but there's other things where once you make them, that's it. Like a string, a character string is not mutable. It's immutable. And so what you need to do if you want to change the value of something that's, if you have a string, if you have A equals a string and you want to modify A to be a different string, you can't just modify the current string. You have to get rid of the current string. You have to dispose of the current string, create a new string, and then set A equal to that string. That is, now, is that important now to know now? I don't think it's important to know now. So when the concept of mutability is important, I will bring that up, and that really doesn't get important until we get into a little bit of it here, and here is where we really get into mutability, where it becomes important to understand the concept. It's where it becomes important to understand things that are mutable and things that are not mutable. It comes into play if you're going to pass an object to a function to do something with that object. The function might take the object and just use the information in that object and do something else, or the function might take that object and want to change it in some way. So if your function takes the object and wants to change it in some way, then that object better be mutable, because otherwise the function will go through the motions, but when the function's all done, that thing is still what it was before. So, and this is different than in other languages, and I don't fully understand why Python sort of seemed to take this more complicated approach to implementing, objects and so on. But I think longtime experienced Python programmers may see a value to it. All right. So anyway, so here's experiments with objects. Run the following code to observe the results of string, type, and ID. Create a new object called age that has a value 19 and print the ID and name of the object. Okay, so let's just run this thing. We have a birth year is, where do we print it? Okay, first we print this. And then we print the word value, and we print what birth year is. So that's the value. And we see birth year was assigned the value 1986. And so that's why this prints out. This printing here is this. And then on the next line, we print the word type. So that's this type. And we want to print the type of birthday year. Well, it's an integer. You can see it's an integer. It's not a character string. So it prints out this as the type. And then we have the ID, and that's like the memory location. That's like where it is in the physical memory. This looks like a memory location. So it's got a memory ID, I guess. And here we're going to print out the birthday month. That's this character string. So first you put a new line. That's why there's a new line here. The words birthday month with an arrow, and the value of birthday month is this character string. The type is class string. And day, again, is an integer. So we've got integer, class integer, and this is where it resides. Okay, so we've seen integers, we've seen character strings. There's also floating point numbers. And, these all use the same bytes, bytes of memory. It's all like, in the memory, you learned about RAM memory and all that, I think, in chapter 1. And it's all how the processor interprets the ones and zeros that are stored in the bytes of the memory. A floating point number is 32. That's in standard computers, or in the old days, I guess it's 64 bits now. Okay, 32. In the old days, 4 bytes was a numbers were stored in 4 bytes. So that's 32 bits. So 4 bytes of so 4 bytes binary number system is 32 bits. So that means it can store a number up to 2 to the 32nd power, which is a pretty big number. It's right up there. But it's a maximum size. So an integer just uses all of its bits. It's a straight conversion from base 2 to base 10. The way characters are stored is it takes there's different character mappings, but in the old days it was 8 bits for a character. 8 bits for a character. That's 256 different possibilities for 8 bits. So that means there were 256 different characters. Of course, now we use more bits and there's more different kinds of characters. So a 32-bit word, as they say, that can store 4 characters. Floating point numbers is a different kind of thing, and that's where some of the bytes of 32 bits, like 1 byte maybe is used for an exponent, and the other 24 bits or the other 3 bytes is the number or the value, the mantissa. And so it's just another way of storing another way of storing a different kind of number, a different type in the same bytes of memory. We're talking about primitive data types here now in Python. And it's kind of like, these are just the manipulation of these types right now are all done directly with the processor. They're done. The processors are designed to manipulate these kinds of types. Later on, when we get into more sophisticated objects and objects that we create and classes and all that kind of stuff, we see that there's a lot more programming involved. There's the compiler and the interpreter that get involved. They aren't basic operations that the processor does. The basic operations are programmed by the folks that write the program that interprets your Python program. Okay, so this is floating point numbers, scientific notation. 6.0. This is, I think this is Avogadro's number. So so like a number like that's this big, 10 to the 23rd power, 6.02 times 10 to the 23rd power, is way too big to store in a 32-bit number or even a 64-bit number, or it'll probably fit in a 64-bit number. But so what is instead stored is the 6.02 is stored in one part of there, in one part, and then 23 is stored. So this is a lot more compact. So this much more compact representation for a much larger number. Of course, the resolution is, lacking, but E equals MC squared. Again, in a Python job, or if you go out and you get a job as a Python programmer, you might be writing code like this, but you're not going to come up with E equals MC squared, or you aren't going to come up with the formula for joules, in mass and kilograms and meters per second and so on. Someone else is going to tell you that. Some smart ass mathematician is going to tell you that, and then you're just going to take that and convert that, and your magic is taking equations which don't look like this. They look like something else with things up on top of each other, and you take it and you convert it into this. You come up with clever names for the variables, not just letters, and not just E. You name it energy or something. Equals the speed of light, the math kilograms, mass in kilograms times speed of light, which is whatever the speed of light is. So anyway, that's how our jobs, the jobs of different folks like this work together. All right, the number of gallons of paint needed to cover a wall is the gallons of paint needed to cover a wall is equal to the wall's total area divided by 350. So that means that so that means 1 gallon of paint can cover a wall that's 350 something area, 350 square feet probably. The program reads the wall area from input, and which represents the total wall area, and then you got to say how many gallons of paint it is. So basically, you just take the total wall area and you divide by 350, and you get the number of gallons of paint. So in other words, if the wall area is 250 square feet, it doesn't give units, it should give units. Then the output is this, because 250 divided by 350 is this. So it only takes 71.4% of a gallon of paint to paint this 250 square foot wall. So you're going to have a little bit of paint left over. If we have a wall that's this many square feet, then that's going to take more gallons of paint. It's going to take 1 gallon of paint to cover the 350, and then it's going to take another gallon of paint to cover the rest of it. It's not going to take 2 gallons of paint, because 2 gallons of paint would cover 700 square feet. We only have to cover 578, so it's 578 divided by 350, and we get this number. So it's one gallon of paint plus this amount of paint. So what are we supposed to do? We're supposed to complete the program to output the number of gallons of paint needed to cover the wall. So it's all this. Let's see. And we're supposed to just print. Okay, I'm going to say num gallons equals wall area divided by 350. I don't think I have to put 0.0, so I won't. I don't think I have to. And then I'm going to print num gallons. That's all I got to do, I think. Let's see if it works. No way I did wrong. Oh, that's weird. All right, I'm going to put 0.0 and see what happens. That's weird. Wonder what I'm doing wrong. Anybody know what I'm doing wrong? Oh, there we go. Rounded to 5 digits after the decimal point. Okay, I got to round it. How do I round it? Ah, look at that. Pay attention. So I'm going to do something like okay, I guess I got to do something like colon point print F this. Oh, what did I just do? Print F dot number of gallons colon point 5 digits 0.5F 5F end curly end quote. All right, I'm going to guess that. All right. Okay. All right, let's do one of these. Let's see, how far are we? I want to do a lab. Or floating point, arithmetic expressions, Python expressions, modulo. How this we're in chapter 2. How many chapter 2? Oh, it's all this. You know, it's 2:44. I want to make sure I do this one. I want to make sure I do this one for you guys. So I'm going to go skip to there. So go through this arithmetic expressions. Here we're learning about the operators, and the right side, the expression on the right side of the assignment statement. Remember that if you see an expression, you always do multiplication and division first, and then you do the addition and subtraction. Those are the precedence rules. Whenever it comes up, I'll remind you what we're doing, and we'll get the precedent. You'll if you don't know the precedent, you probably do, but if you don't, if you get mixed up, you won't. Presumably, you won't get mixed up when this course is over. And then Python expressions, you got to make it look like this. That's what this is about. Oh, you can, like, if you're doing age equals age plus 1, or age equals age minus 1, you can do it this way, where if it looks like this, if you got this like that, you can go like this: plus equals 1, minus equals 1. Age equals age times 1, you just do times equals 1, like that. That's a shortcut. You're not supposed to have commas. Commas are not allowed. All right, let's just, okay, okay, and then division, there's division with floating point numbers. It's different when you're doing floating point numbers than when you're doing integers, because with floating point numbers, there can be like a decimal point, but with integers, there's no decimal point. And then there's another function called modulo, where it's actually the remainder. You know, if you do division, it's like 5 divided by 2, or let's say 7 divided by 2 is equal to 3 with a remainder of 1. Okay, so 7 divided by 2 is 3 with a remainder of 1. And if you just want the remainder, then you do a modulo operation. And that just gives you the remainder. So here, 24 modulo is what it's called. 24 modulo 10 is 4, because 24 divided by 10 is 2 with a remainder of 4. It's 2 with a remainder of 4. So modulo is just the remainder. 50 modulo 50 is 0 because there's no remainder. 1 divided by 2 is 1 because the answer is 0 with a remainder of 1. Okay, so that's modulo. And that's important. You're going to use modulo a lot. And this double slash is integer division, I believe. Floor division. This will round down. So this gets rid of the remainder. Yeah, 5 double slash 2 is 2 with a remainder of 1, but the remainder is thrown away. 5 is thrown away. All right, so that's modulo. Modules we will learn more about modules later. They'll be reinforced later. This dot notation. It's a way to divide up your code. You can put some functions. Some functions are code that you maybe use in more than one place in your program. So you put it in a different little file, and then you access that code by importing the module. And when it comes time to do that, I don't know why we're learning it this early. When it comes time to do that, we'll reinforce that, and we'll reinforce. I can't believe they're covering this stuff so early, because to me it's just confusing. So let me go to driving costs. Okay, this is I'm gonna all right, I better go. I would like to do this advanced beta way of doing it. And so I better go farther ahead where no one's done anything, so I can switch over. The advantage of the beta is that you get a more interactive development environment. It's kind of more the future, but right now they still say that that's in beta. I think this early it might not matter because we're not doing a lot of input output, but here we are doing some input. So let's just leave it this way for now, and maybe starting with chapter 4 or something that's far enough in the future, I can fix that. Anyway, so let's do this one. It's 250. Driving is expensive. Write a program with a car's miles per gallon, and the cost of gas, which is dollars per gallon, as a floating point input, and output the gas cost for 20 miles, 75 miles, and 500 miles. Okay, so we have the output here. This is going to be 20 miles. How much you spend on gas for going 20 miles, how much you spend on gas for going 75 miles and 500 miles. So if the input is 25 miles per gallon and the cost of gas is $3.15, 0.99 cents a gallon, we're going to output this. And the way we do it is we take well, let's just start writing the code. So first we're going to read in these two numbers. So we're going to read in mileage, miles per gallon equals input float input, and I'm going to put in enter miles per gallon. Now this is going to cause the thing to fail. This is going to cause an error, and you can go in and take this out. You go in and take this out before you submit it for your final grading, because it's not expecting that output, and you'll see that it doesn't like that output. But I like to put this in here so we know that the computer is sitting there and you're supposed to be in. Actually, this doesn't make sense when we do our input this way. So I tell you what, forget I said that. Okay, forget I said that. So the computer is expecting the user to input the miles per gallon first, and then the user is going to expect this. Then the user is going to expect an input of dollars per gallon is the price of gas equals float input. And then I want to compute your value 1, which is going to be the 20 miles, and that's a bad name for a variable, but I'm just going to go ahead and use that as a name of a variable. Your value 1, which is it's going to be 20 miles gas for 20 miles. So it's going to be 20 miles well, I'm going to do this. I'm going to make a comment up here. I'm going to say cost 20 miles. I'm going to say cost 20. Cost 20 is equal to it's going to be 20 miles. I'm going to make this a comment so I can explain what I'm doing. Cost 20 equals 20 miles times. Now I want the results to be dollars, cost in dollars. So I want to multiply by something that's dollars, and then the miles and gallons will cancel out. I want to put the miles per gallon and the dollars per gallon in a way where the miles and the gallons will cancel out, and so all that'll be left is dollars. Okay, now this might not make sense to you, but this is like a way that one way of looking at algebra, making algebra be easy for you, if this makes sense. Dollars is going to be it's 3.1599 dollars per gallon. So now gallons is on the bottom, dollars is on the top. We want dollars on the top, and then so dollars per gallon times We want gallons on the top, so it's what is the gallons thing? The gallons is 25 miles per gallon. Okay, so is there a blackboard or something? Is there a whiteboard or something? Okay, I'll write it on the back here. So we want gallons to cancel. So dollars. So to do that, we would have to. I'll just tell you. Divide by miles per gallon. Divided by 25 miles per gallon. Times 20 miles. It's 257. Is there a whiteboard on here? What's does anybody know what what's it called? The board where I can write something in Windows. Does anybody remember what that's called? No, I guess you don't. Whiteboard. It's just called whiteboard. No whiteboard in here? I mean, this is whiteboard's not installed. Well, I guess that's goes. There's nothing I can write with upside down, so I'm gonna have to work on. I'm gonna have to be more prepared. But so this is dollars per gallon divided by miles per gallon, which is the same thing as 1 over gallons per mile, so that the gallons would cancel. The miles are on the bottom, and then you multiply by the miles, and that's what you end up with the value. So this is dollars per gallon divided by miles per gallon, and that's going to be dollars on the top and miles on the bottom, and then this multiplies by the miles, and so that's going to cancel the miles, and we end up with just dollars. And next time I'm going to make sure that the whiteboard works, so I can illustrate this by drawing it out. And so the answer is your value equals the dollars per gallon times dollars per gallon divided by miles per gallon times miles, which is 20. Okay, so that's the one for 20, and your value 2 will be the one for 75, and the last one is going to be 500. Okay, so now that we have all those, I'm going to just copy this and put this down here, and it should, let's see what happens. Let's put in 25 and this, let's put this in. That's what the input's going to be. And when we run this in development mode, we get this is wrong. 3, 1, 2, and 3. What are they called? Oh, 2.539.63. Okay, so that's right. All right, so that's what the answer is. All right, that probably wasn't very clear, but follow along. And one of the things I'd like you to get out of this class, I know that You might not feel super comfortable with math because otherwise you might, well, when you learn computer science with this track, the track here, KCC, and then on to West Oahu, we teach you the math as you go. We don't expect you to know any math when you come in. So my job is to teach you the math as we go. And I didn't do a very good job teaching this math. So next time I'll do a better job. And I'd like you to come out of here feeling a lot more comfortable with the basic algebra math that you need to know. And it's really very simple, and it's practice, and then you're good at it. And so that's a goal for this class, and something you can look forward to. But anyway, this should be enough to get you the points on this chapter 2. And I guess next time we can go on to chapter 3. Are there any questions? All right. Okay, very good. Thanks for coming. The video doesn't work very well, so I will see you next time. Thanks for watching.